In the previous PExpert video, I showed you how to quickly create the analytical solution for transformers using PExpert. In this video, I'm going to show you how to create the PEMAC model based on the PExpert model and extract the resistance, inductance, and capacitance using FEA solver, which is also the Maxwell solver. So here I selected this design from the PExpert with the least power loss. So generate the model. Instead of generate the FEA 2D or 3D based model directly, I always prefer to open the PExpert. Actually, now it is still called the PExpert, but now it is we're going to open it with the PEMAC. I've already created and then run the analysis, so I'm not going to overwrite the existing one. And so this is the PEMAC model, as you can see here. And the reason why I always prefer to open it instead of create like the FEA based 2D model directly is because I like to change some setups first. For example, I always prefer to save the FEA field. This means that the created FEA-based 2D model, which is the Maxwell model, will be saved if I check this box. And if I want to include the capacitance calculation, I can change it. Similarly, if I want to calculate the core as the nonlinear, I can change it. And also, if I want to change the frequency points, I can change it too. And once this setup has been done, we can come here and then start model generation. I'm not going to start the model generation because this has already been created. So once I click the start, as you can see, first it will create the Maxwell 2D model, and then it will run the analysis, and then it will generate the field. And the last step is to extract the inductance, resistance, and the capacitance if the capacitance is included. So because I've already run the analysis, so I can generate the results directly. So I come to the result of FEA-based 2D. As you can see here, I have the AC resistance at the frequency points that we set up. And I can, I have the results with all the windings. I also have the results for the DC resistance. Here we also have the inductance, and the capacitance is also calculated. So as I said, that once I click the start the model, and then this folder will be created. So this is here. If I come to the model FEA-based model start model generation, if I click the start, this folder will be created. And this folder is for the capacitors. As you can see, there's a C here, and this folder is for the inductance and the resistance. If I do not save FEA field, this model and these results will be deleted once the simulation has been finished, because I asked it to save the fields, save the results, so the model and the results are still here. And this model actually is created based on this VB script. And once the simulation has been finished, it will generate the Simplora models or the Saba models or the Spice models for us. So if we want to include these transformers with other power electron circuits and then run these, the system analysis, we can run it in the circuit tool. So now if I create the Simplora model, Simplora design, I can include these transformers to the sub-circuit and then come to the add PExpert static component, and then this Simplora file actually represents that transformer. So this represents the FEA-based transformer we just created, and now we can add other circuit components and run the system analysis. Similarly, if you have your own circuit analysis tool, you can include this transformer either as the sub file or as the Spice model. Another function I want to mention is we can quickly create like the 2D or 3D like short circuit very quickly. Again, I've already created this one, so I'm going to open it. I'm not going to override it. I'm going to just open it. And once we create this one, you'll find this folder. It is called FEA projects. And similarly, you'll see that the model is here. And the results is here. So the model has been opened. As you can see, so the loss has been plotted for us, or like this short circuit. I can ask it to plot like from here, show flux distribution, or like I can just open it by myself and then plot it. And plot the field, things like this project has been solved and all the results are there. I just need to open it and then plot it. I see that the flux has been plotted. And if you look at this current is assigned as if like the secondary has been shorted. Similarly, we can create the open circuit. Like if we create the open circuit model, the secondary, the current for the secondary will be 0. So this is how we can use the PExpert to help us design the transformers.